Hi everybody, here is the video about 4.3, which is about adding and subtracting roots, which can happen, and rationalizing the denominator. Okay, so let's talk about adding and subtracting radicals. Now, radicals or square roots are a multiplying, dividing thing. Like square root of 16 is 4 because it's 4 times 4, so it's a multiplying thing. But you can add and subtract them, but there are conditions, meaning you can only do it sometimes. Okay, we can add or subtract radicals if they are the same root, meaning the same type of root, uh, with the same number inside. For example, like you can combine rad 6 and 2 rad 6. You can actually combine them and they become like 3 rad 6. Let's see. 3 rad 6. Like, so the thing of this is like this means 1 rad 6, like there's one of them, here's 2, and then there's 3. Okay, so these are both square roots, you can do that. All right, these are cube roots, so like you can combine a cube root of 7 with a cube root of 7, you can do that because they're both cube roots and they're both 7. So this would actually become that just like, so 4 minus 3 is 1. And I can't really make cube roots very well on these things. This is a cube root, so 4 minus 3 is 1, so the answer for that would just be the cube root of 7, because that's like 1 cube root of 7, that is 1 cube root of 7. All right, we cannot add or subtract radicals if they have different roots and or the number inside is different, okay, meaning like, so it's different roots. All right, so we can't combine rad 5 and rad 6 because, yeah, they are both square roots, but the 5 and the 6 are different, so you can't do that. We cannot, yes, these both say 7 on the inside. The problem is that's the square root of 7, that's a cube root of 7. You can't combine them. Now, you can multiply and divide radicals like they're with the same root, meaning like you can multiply square roots times each other. You can multiply cube roots times each other. You can't multiply a square root times a cube root. You cannot do that. Unless it's the same number, actually. Okay, so since what I mean is, all right, you can actually do this. Like rad 5 times rad 7 it is actually rad 35. It is. You multiply them and it becomes that. When it comes to something like this, the 3 and the 5 are not in the roots, but you can multiply them together. 3 times 5 is 15. And then 2 and 3 is 6. Yeah, so that's what this would be like. 3 times 5 is 15. 2 times 3 is 6. Do that. You can also divide roots, like the square root of 15 divided by the square root of 5 is the square root of 3, because 15 divided by 5 is, well, 3. And also for this last one, the 18 and the 6 are regular numbers, so that's 3. And the square root of 21 divided by 7 is also 3. So this turns into 3 rad 3. So I'd like to see if you can do this. Yeah, so this means times, this means times. I'll demonstrate how to do a harder one. I'll demonstrate how to do, I'll do 5. All right, so 5, so notice they all say square root of 27. Great, so we can actually combine them. Minus negative 3 minus 3 minus 3 is negative 9. All right, 27, all right, so now I have this. So, but 27 is something we can simplify, because 27 is 9 times 3. It is. And we can get the square root of 9. The square root of 9 is 3. So a 3 now comes outside of the square root symbol, and what's left on the inside is that 3 we did not actually get the root of. And then I can do negative 9 times 3, and that's the answer. And one way to check your answer is like, look, notice that all of them actually equal the same thing. And that's right. So this would be negative 27 rad 3, which can happen. All right, here's the bigger goal of today is your ability to do what's called rationalizing denominator. This is a big thing that has to do with a lot of math. after Algebra 2, if you do pre-calculus, calculus, trigonometry. This is everywhere in trigonometry, which is something you should have been taught last year. You should have been taught this last year in geometry, but here we are again. All right, big math grammar rule. Answers to math questions cannot have radicals in the denominator. Yeah, you can't have that. Like this radical 3 being in the denominator, you can't do that. Okay. So we're gonna so how to get a radical out of the denominator? Multiply times a fraction, FRA. Whoa, that's weird. It like disappears. FRA, fraction, with that radical in the numerator and denominator. Okay, so here's what that question says. It says 6 divided by the square root of 3. Okay, so that is what that says. Now I'm going to multiply that times rad 3 over rad 3. Okay, so when you do this, the 6, so the numerator doesn't, you just kind of combine these two together. 6 times rad 3 is 6 rad 3 over. Now, when you multiply the square root of 3 times the square root of 3, you do get the square root of 9. And we should know by now that the square root of 9 is equal to 3. This is 3. Okay, so now I have this. Now notice that we can actually do 6 divided by 3. That is 2 rad 3. And that is the answer for this one. Let me do this example also. So this says 3 rad 2 over rad 7 equals. Okay, so what do I have to do? I got to get the rad 7 out of the denominator. The rad 2 is fine. The rad 2 is actually okay because it's in the numerator. What we got to do is multiply times rad 7 over rad 7. Now, notice, like, all right, what is rad 7 over rad 7? It's 1. Anything times itself is 1. So multiplying something times 1, it doesn't actually change the value of it. Like, look, if I take this out, it's still 1.6. Hey, it's still 1.6. Like, multiplying times 1 doesn't actually change the value of it. Okay, so what does this become? 3 doesn't change. You actually multiply 2 times 7 in the radicals. This becomes rad 14. It does. And then on the bottom, rad 7 times rad 7. Now, for the sake of just a shortcut to this, anytime you multiply a square root of something times the exact same square root, it just makes the square root symbol disappear. So like rad 3 times rad 3 is 3, okay? I mean, yes, it's square root of 9. That becomes 3. Rad 7 times rad 7 is 7. And that's the answer to that one. That is the answer. And that's how you do these. That's how you do these. And here's some more kind of trying that out stuff. I'm gonna do 17 just so like I can do one more example for you. I got the square root of 15 and it is being divided by 3 times the square root of 6. Okay. Now, we can multiply times rad 6 times rad 6, or we can, let's simplify 15 and 6, okay? 15 and 6 are both divisible by 3, so I can divide 3 out from both of them. 15 divided by 3 is 5 over 3. 6 divided by 3 is 2. So if you notice that, okay, like this is 0.5, look, this is also the exact same thing. Like I just simplified that out. And then you would multiply this times rad 2 over rad 2. Hey, look, it hasn't changed anything yet. Rad 5 times rad 2 is rad 10 over, all right, 3. Then rad 2 times rad 2 is 2. So this turns into the answer would be rad 10 over 6. Then if you look, hey, it is actually equal to what the original question said. Yeah. That'd be the answer for number 17. All right, I hope this was helpful. Have a good day.